Chapter 6, Section 3, Solving Systems by Elimination. This is the third method of solving systems. The first one was graphing, the second one was substitution, and now we'll talk about the third one, elimination. Do a bit of review to get our brain working. So, which of the following does not describe a formula? Do you know? If you picked D, a constant, that is correct. A constant has no variables in it because that's by definition what a constant is, so it cannot be a formula. Circle the formula you can use to find the volume of a rectangular prism. Now, a rectangular prism is a box. So we have length, width, and height. So our volume would equal length times width times height. And for problem 3, cross out the pairs of equations that are not equivalent. Each one of these has a pair of equations. Can you tell which ones are not equivalent? This one is not equivalent because if I subtract k from both sides, that would have been a negative k, not a positive k. You find the other one? This one is not equivalent. If I divided everything by 3, it would look equivalent, but remember, to get the x on the right, we'd have to subtract it. This one is equivalent. If I divided everything by 2, I would get m plus 3n equals 5. Likewise, this is equivalent to the next one. If I subtracted 4a from both sides, I would get b equals 17 minus 4a. So those two are equivalent. Make sure you understand why. We are talking about elimination here. So what does elimination mean? Elimination is the act of removing something. So let's look at it in the terms of the English language. The City Council will not blank the funding for the public library. Correct. City Council will not eliminate the funding for the public library. 5. The blank of the dance portion of the contest was disappointing. The elimination of the dance portion of the contest was disappointing. And last, the new floor cleaner is great for eliminating dirt. Eliminating. So using elimination, we're going to solve this system. So our first step in eliminating y should be that we already have the edited inverse of minus 6y plus 6y. So we don't need to multiply by anything to eliminate that when we add these. So when we go ahead and add these, we have 5x plus 3x is 8x plus or minus 0y, that's just going to go away, equals, and we're going to add those, but 48 minus 32 is going to be 16. So we have 8x equals 16. Kind of did this part already. It should be 8x equals 16 divided by 8, and x equals 2. Now I'm going to take that x equals 2 and I'm going to put into one of the equations for x. So 3 times 2 is 6. So I'm going to subtract 6 from both sides. That's what you get here. So we have 6y equals 42. 42 divided by 6 is 7. So my solution is 2, 7. Solving systems by elimination. Here are the steps. First, we want to look at and determine if we want to multiply the equation by an integer to get the coefficients of x or y opposite each other. So our goal here is to get rid of either the x value or the y value. And so we want to set up our equations, we want to manipulate them so that when we add them together, either our x value will go away or our y value will go away. We will then add the two equations together, which will cause the elimination of one variable. And that allows you to solve for the other. Then we'll take that value once we solve for one of the variables and put it back into one of the equations, it won't matter which one, to get the remaining variable. Let's work through a couple of these. Another sample problem. As you can see, this one's already set up where we can cancel out, eliminate the y's. So I'm going to have 4x because I'm going to add those together. My y's cancel, equals 12. So my x is going to equal 3. I can pick either equation. And I'll put 3 minus y equals 2. Subtract 3 from both sides. So negative y equals negative 1. Multiply both sides by negative 1. So y equals 1. So my point is 3, 1. And that's where these lines cross. The last couple of days, we've been all working on the same final type of answer. It's where the lines, the equations, meet. We're going to solve once again by elimination, but this one's going to be slightly different. We don't have anything we can easily eliminate, so we need to manipulate one of the equations so that we can eliminate something. So looking at this, it really doesn't matter if you choose to eliminate the x or the y. In this case, I'm going to manipulate the top equation. I'm going to manipulate it by multiplying everything by negative 2. And you see if you can figure out why I chose to multiply it by negative 2. So distributing the left-hand side, I get negative 2x minus 4y equals, on the right-hand side, I get negative 34. My second equation is going to stay the same. Now, can you see what multiplying by negative 2 did? Hopefully you see that it set us up so that we can eliminate my x value. So I get negative 3y equals negative 18. So my y is going to equal 6. Now I'm going to take that and put it into either equation. So 2x plus y, here's my y, it's going to be 6, equals 16. So 2x, subtract 6 from both sides, so I get 10. So x equals 5. So my solution is the point 5, 6. And again, we're still finding the solution being where the lines cross, a point that's true in both cases. And here's another case where we want to solve by elimination, but we can't without manipulating the equations. This one is a bit easier if you realize that you have a 2x and a 2x. Well, right now, if we combine these, that makes 4x. But if we take and we multiply by negative 1, that makes our second equation negative 2x minus y equals negative 10. And of course, our first equation will remain 2x plus 3y equals 14. So now we can go ahead and cancel out our 2x's again. And in both these cases, the 2x just seem to be the one to be canceled out. Let me state once again that you can cancel out either the x or the y. It doesn't matter which one. So I have 2y equals 4. So y equals 2. I'm going to stick that into an equation. So 2x plus 6 equals 14. Subtract 6 from both sides. So 2x equals 8. Divide both sides by 2. And x equals 4. So my point is 4, 2. And I should go check this by putting this value back into each of these equations to make sure it's a true statement. 5, 4, 3, 2, 1. In this system, you can see there's no easy number to multiply everything by to eliminate. But what you can do is you can multiply both equations. As long as you multiply every term in the equation, you're not changing the equation. So the equation will remain the same. So in this case, what I want you to do is we're going to multiply the top equation by 3 and the bottom equation by negative 4. And as you can see, that creates a situation where my x values will be canceled out. So I get 17y equals negative 17. So y obviously equals negative 1. So I'm going to substitute that back into one of the equations. It doesn't matter which one. So 3x minus 2 times negative 1 equals negative 10. 3x plus 2 equals negative 10. So 3x equals negative 12, which means x equals negative 4. So our solution is -4, -1. Now we're going to show that this is true for both cases. So 3 times -4 minus 2 times -1, does that equal -10? So I have -12 plus 2. Yes, that does equal -10. So that's a true statement. And then the other one, 4 times -4 plus 3 times -1 equals -19. So -16 minus 3, does that equal -19? It does. So this is our solution. Problem 5. How many solutions does the system have? Well, looking at this, we can combine these. How many solutions does the system have? Asked problem number 5. Well, looking at these, we can combine these. When we combine these, we get -4x plus 10y equals 19. Well, that doesn't really help us, so we're going to take that off. Pretend we didn't do that. So, problem number 5 asks, find the number of solutions. Well, as it is, these can't easily be combined. So I'm going to multiply one of them by -1. That's going to change the sign. So we have -2x plus 5y equals 7. And then I'll have a positive 2x minus 5y equals -12. So if you look at this, these cancel and these cancel. So I have 0 equals -5. Well, is that a true statement or a false statement? It's false. So there is no solution. So these two equations do not create lines that cross. Here's your lesson check. Please do your best to fill it out and bring any questions you have with you tomorrow.